We are going to talk about lines in this lecture. In R3, how to decide a line. You pick a point that you want to start with, and then you pick a direction that you want to go along. So a point and a direction will uniquely determine a line. And the line that's through the point P0, which has coordinates x0, y0, z0, and the direction of the line will be described as parallel to a vector, which means same direction with the vector ABC. There are several forms of equations that we can use to describe this line, to express this line. So the first way is the vector equation, where we are going to use the basis x, I, j, and k. So in R3, you start from P0, which is here in the graph. And then, because we can't really describe points in vector space, so instead of using the point, we are using the vector from the origin to P0, which will have the components x0, y0, z0. Then every point on our line L is pretty much, you start from that P0, then you go along the line. You stop anywhere. I'll use the length they have on the graph. So you go along the direction V, and then this point that you are on, XYZ, will also be a vector. You have that triangle rule, right? So the two sides, when you go along the R0, then you go along vector A, it's the same as you go along the vector R, which have the terminal point XYZ. Then of course you also can go reverse direction as V, you are covering the other side of the L. But you don't have to go exactly same length as V. The vector A, wherever you want to go on this line, could have different length. In order to make the length differ, we multiply by a t. So same direction but different lengths. Okay, that's how we are getting our vector equation R again. So your vector R equals the vector R0 plus some rescaling times V. That's our vector equation. Okay, here R0 is the vector from the origin to the fixed point P0, which has x0, y0, and z0 components. But if you do write out the vector equation into the coordinates, components form, it will be x, y, z equals R0 is x0, y0, z0 plus t times the vector a, b, c. Then if you look at each component, you will have x equals x0 plus at, right, which is this. And then you have y equals y0 plus bt. That would be this. Okay, so if you write them like coordinate by coordinate, you will have the parametric equations. X equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct. So, x, y, z are equal to the base point, x0, y0, z0 plus some parameter t times abc. And in both vector equation and the parametric equation, you have the vector, you have this number t. As I said in the remark, each parameter t give you a point on L. T is how much you are going, right? How far you, what is the rescale of the length. And t is called a parameter. It's like a number that can change. And when it changes, each t give you a point. And when your t goes through all the possibilities, all these points altogether give you a line. Now, if you solve for t in each of these three equations and say they are the same t, so they will be equal to each other, you have the symmetric equations. Okay, pretty much they all equal to the t in the parametric equations. X minus x0 over a equals y minus y0 over b equals z minus z0 over c. So these are the three forms that we have: the vector equation, the parametric equations, and then the symmetric equations. Some remarks. Well, the first one I already said. T is called a parameter, and when t changes, you pretty much are moving along the line and getting different points. The second remark, the line segment from R0 to R1. So this is R0, this is R1. And how do you describe this part? So the equation will be RT equals 1 minus T R0 plus T R1. This is a thing that, when you plug in T equals 0, you just get R0, and when you plug in T equals 1, you just get R1. So then in the middle, you get somehow I don't want to say linear combination, somehow somewhere in the middle between R0 and R1. Okay, so this is a trick in general, but in particular, the line segment has initial and terminal point R0 and R1 look like this. 1 minus t times the initial vector, initial point, plus t times the terminal point. Last remark here, if your a, b, or c equals 0, it won't be a problem when you are writing out your vector equation, because it's like a coefficient of t, right? It will be a term, it becomes 0, disappears. It also won't be a trouble in parametric equation, because same thing, a, b, or c equals 0, you just lose it, that's fine. But when you are having symmetric equations, if a, b, or c equals 0, you can't just say I'm having a 0 denominator. So what happens is, if one of a, b, or c equals 0, you are going to back off to the parametric equations and say, okay, say a equals 0. So this is 0. This is 0, which means the whole term is gone. Then instead of saying x minus x0 over a, which is not defined anymore, we sort of take out the x part. We will say, okay, x equals x0 by themselves, and then we have the y and z aligned together. Okay, so that's a special case when the vector v has components 0 somehow. And then again, the vector equation and the parametric equations will be fine. Just the symmetric equations, when you are dividing by the sort of direction vector, so you need to make sure none of them are 0, and if they are, you just drop that part. Like, forget about it, I'm using the parametric equation for that coordinate. Okay, so that's something you want to pay attention to. Now let's get into examples. The first one, we want to find the vector function, the vector equation, parametric equations, and symmetric equations for the line. Okay, with point 3, negative 1, 3, and the parallel to the vector 3i plus 2j minus k. So I have the point, and I have the direction. Let's do them one by one. The first is the vector equation. The vector equation is the vector r equals, from the starting point r0 plus, I don't know, a rescale of your v. Since we are using vectors, we are going to use ijk. R0 is 3I minus j plus 3k, parentheses it, plus t. Now v is 3I plus 2j minus k. Then I just sort of, work it out. Look at each coordinate. For the I coordinate, I'm having 3 plus 3t I. Then for the j coordinate, I'm having -1 plus 2t j. Finally, for the k coordinate, I'm having 3 minus t k. That's my vector equation. Vector equation is just one equation because, itself take care of I, j, k, like components at the same time. Now, the second parametric equations, instead of using I, j, k to sort of force all the components, different coordinates go together in one equation, you just write them separately. So x equals 3 plus 3t, y equals -1 plus 2t, and z equals 3 minus t. We are taking the x coordinate, the y coordinate, and z coordinate. Finally, the symmetric equation, essentially you are solving t in each of the equation. You minus the constant divided by the coefficient of t. You have x minus 3 over 3. That equals t in this equation, equals y plus 1 over 2. That equals t in this equation, equals z minus 3 over -1. That equals t in this equation. Okay, so that is the symmetric equations. You can also just look at the formula. What it is the variable minus the corresponding coordinate of the point divided by that particular component in your V. Like that. Okay. Yeah, that is the three form of our line. Next example, I'm having, well, this time I'm only asking for symmetric equations. I'm not going to ask you to do all three equations in every question. So to find symmetric equations for the line, still through the point 3, -1, 3, but this time I know that the line is perpendicular to the two vectors, 1, 2, -1, and -2, -3, 1. Okay, so I have a point, I have a direction, but this direction wasn't given explicitly. It was given by saying, okay, it's perpendicular to two vectors. So what's happening? You are having one vector, you have two vectors, and you are looking at the perpendicular case. What is that? That's cross, right? So cross product. The direction of the line that is perpendicular to both vectors will be the cross product. So 1, 2, -1, cross, -2, -3, 1. This is I, j, k with my first vector, 1, 2, -1, and then my second vector, -2, -3, 1. Then I expand it. I'm having 2, -3, -1, 1, I, minus, I'm having 1, -2, -1, 1, j, then plus 1, -2, 2, -3, k. Work it out. I will have 2 minus 3, I, minus 1 minus 2j plus negative 3 minus negative 4k, and that is negative I plus j minus negative 1, then plus k. So that is our vector, which has direction negative 1, 1, and 1. The symmetric equation will be the x minus the x coordinate of the given point over sort of the slope, the x coordinate exponent of the vector, of the direction vector, I want to say. Notice direction vector normally are supposed to be length 1, but here, it's a direction we're going to multiply anyway, so it doesn't really matter whether the length is 1 or not. Now it equals y minus the y coordinate, which is negative 1 over 1, equals z minus 3 over 1. So the point is here. Okay, the point is 3, negative 1, and 3. That's our fixed point. And here, negative 1, 1, 1 is the direction vector. Now I'm going to rewrite the middle part a little bit. X minus 3 over negative 1 equals, also I'm going to drop the 1s as denominator. Y plus 1 equals z minus 3. And that is our symmetric equations for the line through the given point, but also perpendicular to the two vectors. Now you can pause the video and try practice number 1. Next example, we want to find the vector equation of the line segment from 1, negative 3, 5 to negative 3, 1, 3. So R is, when it's 0, you want the initial. So when t equals 0, when the time is 0, the initial point is this. So I'm going to write it as the vector I minus 3j plus 5k. And then you plus t, that is, after the whole time, after t goes to 1, that will be 0, and this will remain. You will have negative 3i plus j plus 3k. Okay, I'm just writing the 2 points as vectors. Then I will again track like coordinate by coordinate. So for I, I'm having 1 minus t from the first part, then minus 3t from the second, that's I, plus my j will be negative 3 plus 3t from the first product, then I have another t from the second, that's j, then I'm having 5 minus 5t, then plus 3t for k. Now I simplify by combining all these like terms of t. I'm having 1 minus 4t for I, plus negative 3 plus 4t for j, plus 5 minus 2t for k. And here, our t goes only between 0 to 1. And that is our line segment. Actually, when you take away that restriction from 0 to 1, you are getting the vector equation of the line, not the segment, the line. Okay, passing through the 1, negative 3, 5 and negative 3, 1, 3. Next example, find the parametric equations of the line through the given 2 points. And then we ask, this is a line, right? So where does it touch the YZ plane? First, we need to find the line. In order to find the line, we sort of go back to the very beginning of elementary algebra. How do you find the line? How do you find the equation of the line? You need the point and you need the slope. So here, the slope in R2 become the direction of the vector in R3. So you have 2 points, pick any one you want, and then you need that vector. The vector of the line is, you already have 2 points. So from the initial point to the terminal point, that's a vector sitting on the line. So I can just use these 2 points and say my vector going from my first point to second point has coordinates 3 take away -8, then -2 take away 1, then 4 take away 4. This gives me 11, -3, and 0. That's my vector. Or the direction, then we want parametric equations, which will be x equals x0. Which am I using? I'm using the first point. Okay, I'm using this point to write my equations. So -8 plus 11t. Then y equals the y value minus 3t. Then z equals the z value 4 plus 0t, or just 4. That's the parametric equations. X equals -8 plus 11t, y equals 1 minus 3t, then z equals 4. The next question, at what point does this line intersect the YZ plane? What is the YZ plane? The YZ plane is the plane that's like in the back, right? So how do you describe it? The YZ plane has, you start from here, then you go anywhere left and right, up and down. So x actually equal to 0. Y and z could be anything, but x equals 0. Okay? And so now you are having a line with all these 3 equations satisfied, and meanwhile you want it to be on the YZ plane, so x equals 0. That force, the 2 things that share x will be the same. So I'm having 0 equals -8 plus 11t. Then I solve it. 11t, well, maybe I'll do the other way around. 8 equals 11t, so t equals 8 over 11. So when x equals 0, if the line touches the YZ plane, x coordinate will be 0, and the only number that will make x 0 is t equals 8 over 11. Then the y and z coordinate, you can just plug in t to find out. So y is 1 minus 3t, which will be 1 minus 3 times 8 over 11. That is 1 take away 24 over 11, or -13 over 11. Now z equals 4. It doesn't even involve t. So no matter what t is, z equals 4. That means the points on our line is x equals 0, y is -13 over 11, and z is 4. This is the point that our line will touch and intersect the YZ plane. Now you can pause the video and try practice number 2. Last, we are going to talk about how 2 lines are displayed in an R3 space. So skew lines are a pair of lines that do not intersect and do not parallel to each other. So again, going back to our XYZ plane, you can have 2 points, 2 lines that are parallel, say y axis and a horizontal line. They're parallel, or if you go sideways but still in the YZ plane, they intersect. But many cases, they will miss each other, and that's skew. So for example, let me choose something not too trivial. So we can choose our x-axis, and meanwhile we choose our y equals 1, like this. So they will miss each other. Okay. Or more general case, if you look at the pyramid and you take this side and this side, they will miss each other. They won't intersect each other because one is going this way, but the other one is sort of like going that way. Is it clear? Maybe it's clearer if you look at the one on the back and the one in the front. They will not meet each other. So these two purple lines are skew. Now let me take away my drawing and let's solve the problem number 5. Example 5. Determine whether the two lines which are given in the symmetric equations, we are going to decide, are they parallel, are they intersecting, or are they skew? If they happen to intersect each other, let's find the point of intersection. So two lines are parallel if their vectors, their direction are multiple of each other. Because now we know that those angles right, and if you make the vector to be the unit vector, then the three components will be the cosine of the line, the vector with x-axis, cosine vector with y-axis, and cosine vector with z-axis. So if they are all the same, then the line has to have the same direction. Then let's see, our first vector v1 is the denominators 1, -2, -3, and v2 is 1, 3, -7. Now let's see if they are proportional. 1 over 1, -2 over 3, -3 over -7. None of them are the same. They are not equal to each other. They have to all equal to the same number to make the two lines parallel. So not parallel. Write it here. Actually, parallel is easy to verify. Intersecting is not. How do you see whether two lines are intersecting each other? Let's go back to the parametric form. We have x minus 2 equals t, and then y minus 3 equals -2t. Well, no, let me write the other way around. So x equals 2 plus t, y equals 3 minus 2t, and z equals 1 minus 3t. These are my line 1 with parametric form. And on the other hand, my line 2, I can't use t anymore. The t are not the same. X equals, so I'm going to use s. 3 plus s, y equals -4 plus 3s, and z equals 2 minus 7. Sorry, that's a 2. 2 minus 7s. If the two lines meet each other, there will be values x, y, and z to make all these equations true, which means in particular you will have x coordinates agrees, y coordinates agrees, and then that's s, and 1 minus 3t equals 2 minus 7s. All these three equations will hold. But of course you are having two variables but three equations. Let's just solve t and s with the first two equations. ignore the third one. So I guess I'm going to cancel t. Multiply by 2, I'm having 4 plus 2t equals 6 plus 2s. On the other hand, I'm having 3 minus 2t equals negative 4 plus 3s. Add them up. I'm having 7 equals 2 plus 5s. So 5 equals 5s, s equals 1. When s equals 1, bring in the first equation, 3 plus 1, so 2 plus t equals 4, t equals 2. So when s equals 1, t equals 2, actually the first two equations, will hold, because you solve them from the first two equations. Now you plug it in the third one, 1 minus 3t equals 2 minus 7s. When you were solving for the s equals 1, t equals 2, it didn't involve this equation. Now let's plug it in and see if still it also holds. 1 minus 3 times 2, and on the right hand side I'm having 2 minus 7 times 1. Actually you do get negative 5 equals negative 5, which means when s equals 1, t equals 2, all three equations hold. And that means the two lines are intersecting at what point? Whatever the value is that make them same. So x equals 2 plus t, which is 2 plus 2, that's 4. And y is 3 minus, that's a 3, sorry. 3 minus 2t, which is 3 minus 2 times 2, which is negative 1. And z is 1 minus 3t with 1 minus 3 times 2, which is negative 5. So the point is actually 4, negative 1, and negative 5. That's where the two lines meet each other. Okay, now you can finish the practice number 3. And that's it for the lecture.